Hello and welcome back to Mrs. Powers Teaches Trig. We're going to put everything together that we've learned so far about reference angles and our unit circle definition of the trig functions to start finding some trig values, exact trig values. That is, we're not going to be rounding. We're going to be just finding the exact value. And we do that by making sketches, by using our reference angles and coterminal angles. So here we go, all of that. So first things first, let's draw an XY axis. And I've said it before, I am kind of against the unit circle. It doesn't have to be on a unit circle. It could be on a circle of radius 2 also. It could be on the circle of radius root 2. Why am I using those? You'll see. Okay, so I'm against memorizing as much as possible. The only thing I need to memorize are basic right triangles, or special right triangles, that is. So here, let's try this again. This one's not too bad. So we got this guy, which is our 30, 60, 90. And that's going to be a short side's 1, hypotenuse is 2, and the long side's root 3. And we have our 45, 45, 90 triangle. And we can find these values, exact values, without using a calculator. Easy enough. 45, 45, 90, 1, 1, root 2. In this method right here. So here we go. 4 pi over 3, where is that? Well, it's more than pi, because it's 3 pi over 3 would be 1 pi, and then it's another pi over 3. So just another pi over 3. That's not more than pi over 2, because another pi over 2 would get us to the next quadrant. So, and no, it's in here. I know it's in here. I'm not going to draw it to scale. I think I actually drew it a little too small, but it doesn't matter. So here, there's my 4 pi over 3 radians. All right. Then I need a reference angle. Well, I know that just a straight angle here is 1 pi. So it's going to be 4 pi over 3 minus pi. That means I got pi over 3 in here, which is my 60 degrees. So pi over 3, that means this guy is pi over 6, and this is 90. And so instead of saying this is I can see I have a 30, 60, 90 triangle. So what I'm trying to say is I'm just going to put a 30, 60, 90 triangle there. I'm going to put my favorite one. In fact, my favorite one is, well, pi over 6 is my small angle. Opposite of that is 1. And then my radius is 2. And opposite of that is root 3. That's what I'm going to do. And not only that, I'm going to make sure, right, if I was drawing this correctly, this would actually be -1 and negative root 3. The coordinates of this point would be -1, comma, negative root 3. And so I'm imagining that the lengths on this triangle are negative in this case, because I'm on the Cartesian plane here. I'm going to use these values. So what's my, since I'm trying to find tangent of 4 pi over 3, in this case, I can do tangent of my pi over 3 of my special right triangle here. Tangent of an angle is opposite over adjacent. So I can see clearly here that opposite my angle is negative root 3. Well, my adjacent is -1. Well, negative over a negative is positive. Over 1 doesn't do anything, so my answer is positive root 3. And that's it. That's how we do these. It's a piece of cake if we got all those pieces to put together. And doing it that way, too, I don't have to memorize this awful unit circle here. I don't have to do that. I don't have to go down, 4 pi over 3 is down here. It's -1/2, negative root 3 over 2. Anyway, and then tangent, you'd one over the other, so you can see that, yeah, it should be positive root 3 because it's sine over cosine. So back to my problem, root 3 is the answer. Let's type in root 3. Root 3. Of course, I'm using Delta Math. I love Delta Math. And there you go. Piece of cake. We got it right. And it does all this other stuff, but I like the way I did it, of course, obviously. Cosecant, 5 pi over 6. We can do one more. Let's do one more. But it's not really necessary because it is the same method for any other trig function we want to do. It's the same. Oops. Here we go. All right, so one more example, and we'll be good. Find the exact value of cosecant 5 pi over 6. All right, so first off, where is 5 pi over 6? Well, 6 pi over 6 would be pi, so I know I'm not passed into my third quadrant. I'm in the first two, probably the second quadrant, because this is close to pi. It's only pi over 6 away, so I'm in here. This guy is, here, this is my x, this is my y. This angle is 5 pi over 6, which means my reference angle, I would need one more pi over 6 to get 6 pi over 6. And that would be how far I'd get to reach back into my x-axis there. So that's going to be pi over 6 right here. So again, I'm using a 30, 60, 90 triangle. I can see that. Oh, that's 30, 60, 90. Pi over 6, pi over 3. And my right angle here. So again, I'm just going to superimpose my favorite 30, 60, 90 triangle. Pi over 3, pi over 6. Pi over 6 is going to be my smallest angle. So this is my smallest side. And then opposite, my hypotenuse is going to be double the smallest side. And then my last side remaining is root 3. That's how I do my 30, 60, 90 triangles. And so now I can easily get cosecant. Cosecant of 5 pi over 6 is really 1 over sine. What's sine of cosecant? So yeah, it's 1 over sine of 5 pi over 6. So it's 1 over that. All right, what's sine? Sine is opposite over hypotenuse. So cosecant is going to be hypotenuse over opposite. And so that's what I need to do. So here's my reference angle. Oh, make sure I have these right. I'm actually back. I'm actually negative in my x, but I'm positive in my y. So this is negative root 3. So my hypotenuse is always positive. And that's something to remember also. And the opposite side, in this case, is a positive 1. So my cosecant of pi over 6 is 2. All right, and let's just double check that in Delta Math, and that'll do it for this video. Woohoo! And then here's its solution, the way it does it. But again, I like my sketch. I think it makes it way easier. So thank you for watching. Until next time, enjoy doing math.